I'm Anil Kumar, and in this video we'll practice how to find inverse normal distribution. It is a very important aspect, and many times when we are using normal distribution, we are given the probability and we need to find the value of the random variable. So that's the kind of reverse calculation which we need to do, right? So in general, the question will be find the value. So let me write down the question. Find the value of normal random variable that corresponds I should say variables, right? It's normally an interval, right? So since we are talking about interval, so find the value of normal random variables that corresponds to the given probability. So that is a kind of question when you need to do reverse work, right? So inverse normal distribution is used when the probability is given to us and we need to find the value of the random variable, possible values. Is that okay? Now some of the very interesting examples are, for example, you appear for some entrance examination into university. They have normalized all their test results and they're only interested in finding those students who qualify for their top 10, right? So we say 90 percentile. So sometimes you'll say 90 percentile. You may see the same thing as top 10%, right? Which is 90 percentile. So where the marks are at least 10 best, right? So that is the kind of thing which they are looking for. So in such cases, what are we really trying to figure out? We're trying to figure out that if they have a normal distribution data, that is to say, let me make one curve here, kind of feel like this, right? So then what they are looking for is, that's the mean, okay, that's the mean. What they're looking for, those who can be in this group from here onwards, right? So 90% top students, this group. Do you get an idea, right? So they're looking for those students who could qualify by being in top 10, correct? So let's say we give some value here, then we are looking for that number. So in that case, what is their z-score? So that this is greater than 90%. Do you understand? This value is greater than 90%. So that is what they are looking for, right? So the z-score probability is given to us. So that could be one kind of question. Or many situations we are trying to find what is the, we know that the distribution is kind of like this, and let's say from the center we want to accept a lot of production. We know that the mean is given to us and everything which is in between an interval qualifies. For example, something which is within plus and minus some percent, right? Let's say something which is uniformly distributed in between around the mean, right? So this portion, right? So we are looking for that kind of a result, right? So we want to know what is the value of the random variable which will satisfy that kind of criteria, right? Or we might have a case where we are looking for the probability that it should be at least this much. I mean, kind of like this. Okay, so to qualify for these standards, it could be at least this value, at least this value. Is that okay? So these are different scenarios which we can work with. So in the language of probability, we can say, let's take all of them with normal distribution to make things simpler. That means mean is 0 and standard deviation is 1 for us, right? We'll take up another video where we'll complicate the situations and we'll do the examples which I really talked about where the scores have been normalized, okay? So let me first take some very basic examples, and in all these examples we are going to use our standard normal distribution table values, right? So from here we can read the values which are from the left side to the point A, right? So that is kind of table which we have to work with. Is that okay? So that is what is the base for this particular video, right? So what we are trying to find here is that, so Z scores are given. We'll call this as Z0. That particular score which we want to find is, what is that value of the random variable which is going to satisfy the condition, right? So in this particular case, let's find the probability. This could be represented as probability when the Z-score is greater than that number, right? And that is equal to top 10%. That is equals to, let's say, 0.10, right? Top 10%. So this portion, small portion. So what is the value of Z0, right? This is one probability. Where we are given the probability, we need to find the value of a random variable. You understand, right? In this case, what we could look for is probability when the Z-score is between two numbers. So these two numbers are minus Z0 and plus Z0. Is that okay? So kind of like this, symmetric about the mean, right? Symmetric about the mean, which is 0 for us. And in this case, our probability could be where Z is less than that number, right? So these could be different scenarios. Okay. So well, based on this, we can have many equations. So here I gave you a value. So where I'm saying that the probability is such that this is greater than this. Now let's see how to solve the first one. Since we are using our tables which gives us values from left to right, we can read what is up to that point, minus infinity to that Z0, right? So that is what we can read from the table. So let me change this value in that language. So we can write this as probability where the Z-score is, if I make it less than, if it is greater than Z0, it is 10%, but if it is less than Z0, it should be 1 minus 0.10, which is 0.90. Do you see that? So the probability for Z is given to us as 0.90. Is that okay? Now 0.90. So we are given the probability, which is pretty high. So now we kind of changed it. So we are saying greater than this means if I see from left side less than Z0 is 90%. So left side is 90%. Do you see that? Combination is 100%. So this is your left side, correct? From the same points, So we'll get the value of Z0. Is that okay? So 0.9. This is a very important value which we'll be using many times. So as I said, 0.9. So if I look into the values, we have this going to 8, 9. So if you see this value, 1.2, so the value, this is 0.90, 1.3. If you go back, so it is kind of 0.899, right? So this is very close to 0.9. You could take this or that. So we prefer to take this one, 1.28, right? So I'll take 1.28 as this value. So we are reading from the standard normal distribution. That's the probability. This probability corresponds to z-score of 1.28. Do you get the idea, right? So that is inverse normal distribution. So that gives us z-score. We say this is for z-score of 1.28, right? Actually, I should have written here. Once you read that, then you get this probability of 0.9 is for z value less than 1.28, right? That gives you 0.90. Therefore, z0 should be 1.28. You get an idea, right? So that is how it is. Let's do the next one. Let me take a concrete example. So let's say that the probability of something in between is equal to, so we know one standard deviation is this much area is normally 68%, right? So we say this is equals to 0.6. Let's say 60, okay. 60%. Then what is the value of minus z0 and z0? So well, that really means that half of this is 30%. Is that okay? Full is 60. So we say that probability for z to be greater than z0 minus z0. So this is minus z0. Is it okay? Or 50, whatever. We'll just say like this. Minus z0 and z. Probability between these two positions is equals to how much? 50 minus that. 10. Is it okay? So if this is 30%. If I say this is 60%, let me write like this. This is 30%. Is it okay? This is 30. This is 30. Now, if I want to find z0, since I am using, see, my criteria is I'm using this kind of a table, right, to read the values. They give me from minus infinity, right? So to give you an idea why I'm right, kind of. So my table gives me values from left. So if I'm trying to find a value here, my table gives me values from the left side. So I have to write probability in terms of what is it from the left side. Is it okay, right? So let me rewrite this. So we want to find what is left side of this. That helps. Is it okay? So what we found is if 60% is total, 30 is this half, correct? So this is 50% here, correct? So 50 take away 30 is 20%. So this is 20%. Is it okay? So we could say that the probability for z to be less than minus z0, because this is a negative value, is actually 20% or 0.20. You get an idea, right? So we could find this, and the other one is the positive value of that. Is it okay? So 0.2. So we can look into this value, which is 0.2, right? So 0.2 negative value we're looking at. So let's get back to our table. Look for 0.2 in probability. So in 0.2 in probability is somewhere around this place, 0.200. So that is 0.2, right? Minus 0.84. So minus 0.84. So this is for when z is less than minus 0.84, right? So this is what we read, is equals to 0.20. So the value z0, it is the interval is between, that means z is between minus 0.84 and plus 0.84. You get an idea, right? So that is how we could get this value. Is it okay? The last one is kind of simpler from our tables because that directly gives you the value. So let us say this is equal to, let's say 0.05, for example. Okay, 0.05. Okay, so that is just 5%, correct? So what is Z0? So what Z-score will give me 0.05. 0.05 will be, let's read. So we have 0.0345 somewhere here, okay. 50, that is a good value. So minus 1.64, minus 1.64. So that is minus 1.64. Is it okay? So that you get when Z is less than minus 1.64. You get 0.05 approximately. Therefore, this Z0 is probably equals to minus 1.64. You get an idea, right? I hope you understand how we can use inverse normal distribution to find the value of the random variable for the given probability. So these are different scenarios which can help you to figure out the value or the interval for the random variable when the probability is given to you. I'm Anil Kumar and I hope that helps. Thank you and all the best.